Hi, my name is Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is a supplemental resource to anyone who may be needing some extra help in their chemistry classes. This week, I'm going to be talking about balancing chemical reactions and different reaction types. So if you need help, feel free to continue watching. And without further ado, let's get started. Okay, so at the end of my last video, I talked about the law of conservation of mass and how when you're writing chemical reactions, it's important that the number of atoms on the reactant side always equals the number of atoms on the product side. And this is also true for mass. So the mass of the reactants should always equal the mass of the products. And this is why we balance equations. So often you might be given an equation that is not balanced and the law of conservation of mass is not consistent. So you'll need to add coefficients in order to make sure there are the same number of atoms of each element on the reactants as there are on the product side. And there are some rules for when you balance. So first, you can't add any new reactants or products. This messes up what occurs in the reaction. Also, you cannot change subscripts of a compound because that then changes what the compound is. So for instance, H2O is different than OH. I took away a hydrogen, so the chemical formula is changed. A new substance is created that is a chemical change. And that does not work for balancing. And finally, you can only change the coefficients of a compound in order to balance the chemical equation. So we are going to do an example with aluminum oxide yielding aluminum and oxygen. So you know this from writing ionic compounds, that the formula for aluminum oxide will be Al2O3, and that yields Al plus O2 because O2 is oxygen is diatomic. So I'm going to move this up a little bit. The way I like to balance chemical equations, at least in the beginning, is with making a chart. So I like to make a chart and write each of the elements I have on each side and write how many of each of them I have so I can keep track. So on the left side, I have 2 aluminums and 3 oxygens. And on the right side, I have 1 aluminum and 2 oxygens. So now we have to put coefficients in front of the ALs and the O2s in order to make sure both sides are equal. So I'm going to start by putting a 2 in front of the aluminum. And that will then make this 2. So our aluminums are now good. However, I cannot add part of a coefficient. I can't add 1.5. I have to add a whole number. And there's no whole number I can multiply O2 by because there's 2 O2s in order to get an odd number. If I multiply by 1, I'll have 2. Multiply by 2, I'll have 4 oxygens. So what I'm going to do is find a common multiple between 3 and 2, and that is 6. So what I'm going to do is multiply this oxygen by 3. So now we have 6 here. And then I'm going to put a 2 in front of this. So now we have 6 oxygens here. However, that then alters the number of aluminums. We now have 4 aluminums. But we can change that by changing this coefficient to 4. So again, because I can't multiply an even number by a whole number to get an odd number, I had to use the common multiple. So I'm going to rewrite the equation just so it's nice and clean. We have 2 Al2O3 yields 4Al plus 3O2. Okay, so our next example is calcium nitrate plus sodium phosphate yields calcium phosphate and sodium nitrate. So in these, we have polyatomic ions. And it's important that polyatomic ions are treated as one unit. So when we make our chart, we're not going to separate nitrate into N and O. That is just going to be more complicated. We're going to write it as NO3. So I'm going to quickly figure out what the formulas for each of these will be. So Ca is a 2 plus, nitrate is NO3 minus, sodium is Na plus, phosphate is PO4 3 minus, and then I'm just going to rewrite it on this side. So I'm just doing this so I know what the formula is going to be. Now I'm going to write out my reaction. So I have CaNO3, 2, because I'm trying to make the charges, I'm making sure that the charges cancel out. And I have plus Na3, PO4 yields Ca3PO42. And for this one, just like this is another instance of where we're trying to find a common multiple. This will come up in different ways. In this one, our common multiple is 6 with the charges. So I have 3 calciums and 2 phosphates. And then plus NaNO3. Okay, so I'm going to draw my nice chart. So I have CaNO3, Na, and PO4. And I'm going to put them in the same order on the other side, just because I feel like it helps it stay organized. And now I'm going to go through and fill out what I already have. So I have 1 Ca, 2 NO3 on this side, 3 Na, and 1 PO4. On this side, I have 3 calciums, 2 PO4s, 1 sodium, and 1 nitrate. Okay, so I'm just going to go in any order. I'm going to start with the calcium. So if I put a 3 in front of CaNO32, I'm going to have 3 calciums now and 6 nitrates. Now I'm going to adjust it on this side. I now need 6 nitrates on the right. So I'm going to put a 6 here, which will make our sodium 6 and our nitrate 6. Now we need to alter our sodium back on the left. It's kind of like a ping pong. I'm going to now put a 2 in front of Na3PO4, which will give me 6 sodiums and 2 phosphates. And now we have balanced our equation. And that is how you balance equations. I like to, in some cases, there will be a specific order you should go in, which you'll discuss as you get more advanced, and probably in further videos, I'll talk about it. But this chart really helps me and helped me out when I was originally learning how to balance equations. It organizes everything really nicely, and you can kind of keep track as you're going of how many atoms of each element you have, so that you can make sure you are staying consistent with the law of conservation of mass. So now we are going to talk about different reaction types. First, you have a synthesis, which is where you have 2 elements come together to make a compound, or an element and a polyatomic ion come together to make a compound. So A plus B yields AB. An example of this is 2Na plus Br2 yields 2NaBr. Keep in mind this example is balanced. Next, we have a decomposition, which is when a compound decomposes into its respective parts, 2 elements, or an element and a polyatomic ion. An example of that would be 2NaCl yields 2Na plus Cl2. And as you can see, these 2 examples are opposite directions. So one is putting 2 things together, the other is decomposing them and taking them apart. Next, we have a single replacement, which is when you have AB plus C yielding AC plus B, or AB plus C yielding CB plus A. So only one thing switches. In this first example, the B and the C switch. And in the second example, the A and the C switch. So this will usually be when you have a compound plus an element, or a compound plus a polyatomic ion. The specific thing with single and double replacements is that metals need to replace metals and non-metals replace non-metals. You cannot have 2 metals in your product. You have to have 1 non-metal and 1 metal. For instance, this is with metals replacing metals. We have CaI2 plus 2Na yields Ca plus 2NaI. So as you can see here, Ca is a metal, Na is a metal, so the metals replace each other. An example with non-metals replacing each other is 2AlBr3 plus 3F2 yields 2AlF3 plus 3Br2. As you can see here, bromine and fluorine are the non-metals, and they replace each other on the product side of the reaction. Next, we have a double replacement, which is when both the metals and the non-metals switch places. However, they only switch places with each other. AB plus CD yields AD plus CB. So again, metals and non-metals switch places. You cannot have 2 non-metals or 2 metals in a compound. An example of this is 2AgNO3 plus Na2CO3 yields Ag2CO3 plus 2NaNO3. So in this case, we have a metal for Ag, non-metal NO3, sodium is a metal, carbonate is a non-metal. And then if you notice, the metals both switch places. which also causes the nonmetals to, by association, switch places. So this is now a metal with the other nonmetal, and this is a metal now with the other nonmetal. So these are kind of grouped together, but a double replacement has one additional switch. So a single replacement has one switch versus two switches. Now these are more of a specific case. We have neutralizations and combustions. So neutralizations have the formula of an acid and a base yields salt and water. Neutralizations are technically double replacements because you start with two compounds and end with two compounds. However, not all double replacements are neutralizations because a neutralization has to have more specific characteristics. So an example is 2HBr, which is an acid, plus MgOH2, which is a base, yields water, and a salt, MgBr2. And a salt is any ionic compound. So as you can see, technically the metals switched and the non-metals switched in this case. Finally, we have a combustion reaction, which has characteristics of similar detail to a neutralization. A combustion reaction is made up of a hydrocarbon and oxygen, which yields carbon dioxide and water. An example is C3H8 plus 5O2 yields 3CO2 plus 4H2O. So a hydrocarbon is anything that has carbon and hydrogen. And it is added to oxygen to combust and make products of CO2 and H2O. Quite straightforward. These just are very specific, and you have to make sure that you categorize different reactions correctly. So all these abbreviations, S, D, SR, DR, N, and C, you can abbreviate the different reactions like that. But this is just an in detailed look as to what each of the reactions look like. And in a future video, we will be predicting the products. So it's important to know how each of these reactions will start and end up. So now we're going to do some individual practice, classify these 4 reactions and also balance them. So give this a shot on your own, and then I'm going to go over it. Okay, so let's go over this individual practice. So ZrCl4 plus 2Mg yields Zr plus 2MgCl. This is a single replacement. I'm going to just abbreviate that here. Because I know this because we have a compound and an element, not a compound and another compound, but this magnesium, it's by itself and it switches places with the other metal, zirconium. And I balanced it with my table over here. Then we have Zn3p2 yields 3Zn plus 2p. This is a decomposition. This is a decomposition because we are starting with a full compound and splitting it up into its 2 different parts, elements. And I just balanced this by putting coefficients in front of the zinc and the phosphorus. Next, we have 2Al plus 3S yields Al2S3. This is a synthesis reaction. It's kind of flipped from the decomposition reaction because we are starting with 2 elements and putting them together to make a product instead of splitting up the big compound, which is still a reactant in a decomposition, into 2 elements. So in synthesis, elements are reactants. In decomposition, elements are products. Same thing, I balanced it with the chart. Finally, we have a double replacement, and the metals switch places with the metals and the non-metals switch places with the non-metals, as is the case with the double replacement. Something to notice here is with H2O, I find it easier to rewrite it as HOH because we have OH in the beginning of this reaction. So you can then write OH as its own category on your chart and just say like that you have 1 H and 1 OH to start off and balance with. And then you can rewrite it as H2 and win your reaction once it's balanced. But yeah, so that is the individual practice for this video. So that was this week's video on different reaction types as well as balancing chemical reactions. Next week, I'm going to talk about predicting products and balancing algebraically. So make sure you have a solid understanding of what the different chemical reactions look like so that you can easily predict the products, and make sure you practice balancing them because balancing algebraically is slightly more advanced. I hope you enjoyed the video. I'm going to leave a link in the description box to my website if you would like to schedule tutoring with me. And as always, if you have any questions, feel free to leave them in the comments and I will do my best to answer them. Good luck with learning the rest of your chemistry.